So the purpose of this video is to show you how to fit peaks. This is a pretty useful thing to be able to do for a variety of labs, so I wanted to make sure that you had a reference that shows you how to go about it. So I'm going to show you two different methods. First method is in Matlab, and the second one is in Excel. So you should have everything you need to be able to do it one way or the other. So to give you some data to look at, this is data from the Bohr model lab. So spectrometer data. So to do this in MATLAB, how you would do this in MATLAB is you're going to use something called the curve fitting toolbox. And we are just going to, I'll show you how to copy and paste your data from Excel into MATLAB. So what I would recommend is just make a couple variables, X and Y, whatever you want to call them. You just double click on the variable in here. You'll bring up something that looks like a spreadsheet. And then if you go to your data and copy and paste it, you can just copy and paste it into MATLAB. You can be more sophisticated about this, but I think for what we're getting up to, this is the easiest way to do it. Should be able to just copy and paste. So we've got our list of wavelengths. And our list of power measurements. So just make two different variables, paste them in there. We could, you can do all kinds of stuff. The goal with this is you're not going to have to write any code or anything like that, but because I know not all of you have used MATLAB, so we're going to make it as easy as possible. We have X and Y in here. You could plot and otherwise manipulate them if you would like, but we're going to just use the curve fitting toolbox. Note, if you don't have this under apps, you can add it by, it's probably just not installed. If you click on get more apps, you should be able to find it, curve fitting toolbox, and add it to your MATLAB. So since we have the variables in there already, all you have to do, select X and Y for your X and Y data. It shows up in here. The type of fit that we're going to use is Gaussian fit. And there you go. So it fits, right now it's fitting one peak. If you want to have it fit more peaks, just add more, change the number to fit more peaks, and it's as simple as that. And a couple reasons why this is nice. So it gives you, so you'll notice the Gaussian expression looks like e to the negative x minus x naught quantity squared over c squared. And so if you look at the function and then look at the numbers that it has fit to it, A1 would correspond to the amplitude of the first peak, B1 would correspond to the location of the first peak, C1 would correspond to the width of the first peak, and then A2, B2, C2 would be for the second peak, etc. And it's nice because it's fitting the amplitude, the location, and the width. The thing that we want right now is basically the location. So that would be this B number, and it's found it to be 654.8. So it has found the location of a peak better than we to a finer increment than the data. We have data points every 1 nanometer or so, and this has found the location of that to a fraction of one of those points. And then not only that, it's also given us an error bar. So I think this is how is this specified? So this is 95% confidence bound, whatever exactly that means. It's given us an error on that peak, which is nice. So it's located all 4 peaks and given us other parameters, their width, their amplitude, and how well it knows them according to this confidence bound. You can imagine a lot of different circumstances where you might want to fit a peak, maybe some other application you want to extract how big the peak is. This would give you a way to do that. So that's what I would consider the easy way, doing this in MATLAB. Now, notice you didn't have to write any code or anything. You just basically pasted the data in here and had the curve fitting toolbox do it for you. Uh, the little bit more complicated way, you can do it directly in Excel. So let me show you how to do this. To do this, what we're going to do is we're going to do basically least squares fitting manually. So we will make a column for the function, and we'll have to do it manually, but we know kind of what it looks like. It's going to look like, all right, let's put our parameters here. We need the amplitude. We're going to need the location, and we're going to need the width. So the amplitude, let's focus on the big peak because that's the one that's easier to get a handle on for now. You can tell the amplitude of this is going to be about 12. The location, we know it's about 655. The width is, I don't know, it's 10 or something like that. Okay, and the function then is going to be the amplitude. Now I'm going to fix these numbers because these are constant. Exponential, it goes like negative x minus x naught. Fix these values. Squared over the width. I think it was squared actually. It doesn't totally matter. It'll behave the same way. And that width number also doesn't change. So notice this gives us a little tiny number. I found for whatever reason I had to multiply explicitly by -1 to get this thing to work. Anyway, manually entering the Gaussian function, fill down the column. You can see that they're basically all 0 except close to the peak. If we want to visualize this, we can add this as a series. Let's do that. Add a series for our fit. Just got to select the x and y values. So the wavelength and fit values respectively. And notice it shows up now in orange. It's clearly our width is too big. Let's tweak that a little bit. And you can see we're starting to get, not a bad kind of rough approximation of the peak. Now, to have Excel tell you exactly what the peak is, what we're going to do is we're going to take the squares of all the differences. So basically, just take the difference between our fit and the experimental data squared, and we're going to do that point by point. Why is it second? Okay, so evidently why is it displaying so many numbers? Excel. Excel being Excel. I don't need a million digits. And then we're going to add all of these up. So, and this is telling you, basically how far off. It gives you one number that's giving you information about how far off your fit is from the actual experimental data. And then what you do to have Excel optimize this is you go to data and you go to the solver. So if you don't have this, it's right next to the data analysis thing, which you would use to do regression analysis. If you don't have the solver in here, you would have to install the little solver plugin just as you would the data analysis plugin. So you just click on this thing, it brings up this menu. Our objective is going to be this cell where we have the sum of all those differences squared. And what we want to do is we want to minimize it. So we want to minimize that parameter by, or that cell by adjusting these parameters. And that's what we're telling Excel to do. You say, click on solve, and let's see if this thing works. So it chugs a little bit. And let's see, did it find some values? Yeah, so notice it adjusted these values a little bit. We had 12, 655, and 5, and now it's a little bit larger, 64.79, and a width of 2.82, and we get nice agreement between those two. So in this case, we have had Excel do the optimization to find the peak, and the thing that we were most interested in this case was, basically the value of the location of the peak, and it has located it for us to better than a nanometer, which is pretty cool. Now, it doesn't automatically spit out any sort of error bar or confidence interval or anything like that, but it does give us, a much more precise value than we could get by just kind of eyeballing it or assuming where the peak is. The other thing that we can do, so if you want to fit more than one peak, what you would do is you can add, you'll have to do it manually by adding another term to your Gaussian, but let me see if we can do that. So these were just, for the first peak. Let's try and get this peak as well. So I'll call this one A2 to C2. How about? So we know in this case the peak is going to be, it's like 485, or wait a second. The amplitude looks like it's going to be about 3.5. The location is something like 485, and the width, I don't know what the width is. Let's say it's 2. It's a little bit skinnier than the previous one. And then what we would do is inside of our fit function, now we can add another term. And what will that term look like? Well, it will be this amplitude times exponential times our x minus, now we have a new x naught, corresponds to that peak, that thing squared, divided by this second width squared. And so we've added manually a second Gaussian peak. And let's see what effect that has. So we can see it reflected in our fit. And so now if we want to get Excel to adjust those parameters, we have to rerun the solver. And we're still optimizing for the same location, but we're going to change which values we're going to change. We're going to change all of these. And let's have it run again and see if it can give us results for that second one. Let's see, did it give us better values? Choke. Yeah, so it updated our values a little bit. These ones didn't change, but they changed a smidge. And then the second ones, it located that peak, gave us an amplitude, gave us a location of 485.97, which is really close to what we expect, as well as has given us a width. So you can see how if you wanted to do this, for more peaks, you want to do this for, A3, B3, C3, you could do that. It's just going to add more terms. It's going to make Excel work a little bit harder. I suspect if you had to asked it to try and fit enough peaks simultaneously, it's probably going to break. But for what we're getting up to of fitting a few peaks, this shows you how you can have Excel do it for you too. So I hope this is helpful for you as a reference. Two different methods of fitting peaks, one in Matlab, one in Excel. You should kind of have everything you need to be able to do that. And I think this will be something that will be useful for you, in multiple labs, as for our class, as well as in other contexts too. I think you probably run into situations where you might want to fit a peak, and so this is a couple of easy ways to do it.